So we'll take a little bit of a look at the coupler that goes between the DC and AC motors here. It took me so very long and delayed testing by almost 2 months. So I happen to have some aluminum tube. This is 4-inch square tube, 1/8 inch wall, and the distance when you lay them end to end between these two motor faces is just about 5 inches. It's a hair under 5 inches. So what I did was I put 4 inches here, and the 3/4 of an inch is made up by those tubes on the end there. It was intended to be top and bottom, but that's not how the bolts lined up. The bolts lined up kind of upper left and lower right. Sorry, upper right and lower left. So that's how I've got it done. There's 2 bolts here and here in the motor on the DC side. And then there's 3 bolts on the AC side, so I made those longer and I put these spacers in, 3/4 inch spacers. And you'll see on these tubes that it took me quite a few tries to get the holes in the right place so that the motor is lined up the way they're supposed to. I'm not mechanical, and it is illustrated to me every time I try to do one of these things. In any case, it seems to be fairly rigid right now. The motors do make noise, and I have a video I'm going to show you where there's a little gap between the joy couplers. I've also got a little bit of an explanation of the joy couplers I can show you. But this is about as good as I'm going to do, so I'm not going to mess with it anymore. The next step for me here is either to get a DC controller going, which is probably what I should do, or I can continue using lower voltage batteries and put energy into the DC motor and regen out of the AC motor. But in order to do that, I have to get some cooling to the motor with these 2 connections on the end, and I need to get some cooling to the AC controller, which this is a big aluminum heat sink, and I need to put a chill plate on the bottom of it. In any case, that's where I am right now. I believe that I can do a load test, and I will do load tests of short duration, just to get some data to Paul. But they will be quite short duration because the 12-volt batteries will not sustain very much power into the DC motor. So if there isn't much DC power going into the DC motor, then the AC motor won't be able to regen very much. And I'm hoping to get in the range of rated for the motor, which I think is 400 amps. 300 amps. In any case, I keep getting that mixed up. I'll look it up. This is a smaller version of the joy coupler. This one goes over one side. There's a Allen wrench and a key. So the key goes in the shaft and keep it from spinning around, and the Allen wrench kind of lets it's a pointy Allen screw, goes into the key and doesn't allow it to slide back and forth. Then you've got what is called this spider rubber thing, and then you've got another shaft of another diameter that can be coupled to it. So this goes in here, this goes on one shaft, and then this slides in and goes to the other. And this is a smaller version of what's being used in there. So this joy coupler, this is a hard shaft from the DC motor going in here. Spin it around so you can see the Allen key, the Allen screw goes in here. Then the rubber spider, and then this other coupler that goes on the end of the AC motor and is screwed down to the key. Now the thing is, this back here, you can't really see it, that going into the face of the AC motor is an adapter from a spline, so it's not held there real tight. So this little bit of a gap here, you can see in between. Let's see if I can zoom in there. That little bit of a gap there, I think, is one of the reasons that it's making noise. I also don't want to get it too tight because I don't want to put any pressure on the end bearing on the AC motor. But I think that's the source of all the noise we're hearing.